Alright, ladies and gentlemen, today's lesson is Stretching and Shrinking 3.3. I'm coming to you from my basement, and I'm missing the beginning of Once Upon a Time so that I can record this, so I want to hurry through it. Today's lesson is Scale Factors and Similar Shapes, and it comes to us from page 42 in our book, Stretching and Shrinking. Your practice problems are going to be 1A through C, then you're going to be skipping ahead and doing the ACE problems 7 through 21, 32, and 38 through 42. And your learning target is I can find complex scale factors. Okay, so ladies and gentlemen, let's go ahead and get started. For the notes, we're going to be finding scale factor. To find the scale factor, you divide your new shape. You divide your new shape from the old one. I probably needed to add that detail in. From the original. I missed that. Sorry. So you also need to remember the direction that we're dividing these things by. So let's go ahead and get started with this one. If I have A here that is 4 high and 8 wide, I find a corresponding side with B here, and in this case B is 2 high and 4 wide. Let's say I'm going from A to B. If I'm going from A to B, I would divide my new shape, okay, which is 2, and divide it by its corresponding side, which would be 4. And that would reduce down to 1/2. And that would be my scale factor. Now, if I was to reverse that, if I was to go from B to A, well, now B is my original shape. So I would put my original shape underneath, and I would divide by its corresponding side, and I would get a scale factor of 2. And that's where this part, remembering direction, comes in handy. Okay? So, if I'm going from A to B, my scale factor is 1/2. If I am going from B to A, my scale factor is 2. So, I'm going to start at now by working actually on the first problem in your practice. So this actually is going to be a little bit of a help on your actual coursework. So for lesson 3.3 practice, from page 42, direct from what you're going to be doing, problem A. Problem A says for parts 1 through 3, draw a rectangle that is similar to rectangle A that fits the description. Well, they're going to give us 3 different descriptions. And rectangle A is 4 high and 8 wide. How about that? For our first one, we want the scale factor from rectangle A to the new rectangle to be 2.5. So, how big will this be? Well, originally, it's 4 to 8. And remember, I'm going from rectangle A to my new rectangle. And if I'm doing that, I'm going to have to do 2.5 times 4. And 2.5 times 4, let's see here. Well, 2 times 4 would be 8, plus half of that would be 10, because I'm adding 2. So I would have a 10 tall by, well, how wide? Going from 8, so 2 times that would be 16, plus another half, and half of 8 is 4, we would get 20. So 2.5 times 4, 2.5 times 8, and we get our new sides. Okay, for number 2, the area of the new rectangle is 1/4 of the rectangle of area A. So we have this mystery rectangle here that has a quarter of the area. Well, this is something to keep in mind. Am I dividing everything by 4? No, I'm not. The important, tricky part of this is area. So what is my area? Well, 4 by 8 gives me an area of 32 cubic units. Okay? Or square inches, square feet. I don't really know what we're measuring this in. I just know it's 32 squares. And I need to find 1/4 of that. Well, if I multiply it by 0.25, or if I multiply it by 1/4, or find 1/4 of that, or divide it by 4, I get an area of 8. So I need something that has an area of 8 that will fit this, that will be similar to this. Okay? Well, similar to this. Well, I just need to kind of go up the sides. Well, if I make it 1 by 2, which would be the same, I would only have an area of 2 units. That's no good. If I make it 2 by 4, I get, oh look, oh, that's a little too big, sorry. 2 units by 4 units. That is similar as well, and it matches the 8. So if I have 2 by 4, I get an area of 8 cubic units, and I'm similar. I'm similar because I'm basically multiplying everything by 2, right? If I wanted to go up to this, I would just multiply everything by 2, or I would be multiplying by half if I'm going the other direction. Either way, it's similar. And for the last one, the perimeter of the new rectangle is 3 times the perimeter of A. Well, I need to find out what my new perimeter is going to be. Well, here's the fun thing about perimeter. How do we find perimeter? Perimeter is just finding the length of all the sides, and in this case I'm multiplying by 3. Does perimeter go up along with scale factor the way that a side length does or a corresponding side does? Absolutely. So all I have to do is multiply everything by 3. So instead of being 4 wide, 4 tall, it's going to be 12, and instead of being 8, it is going to be 24. And if I wanted to double check that, if you check the perimeters of both of these, you would find them to also go up by 3. Okay, so with that kind of explanation there, what have we learned from this lesson? We've learned from this lesson that we're sort of taking the skills we've learned in the last 2-3 investigations, the idea of similarity, the idea of area, the idea of perimeter, and understanding those patterns and applying them into some harder problems. And those problems are going to be found on page 42 through 43, A through C. We just did A together. And the ACE problems are going to be 7 through 21, 32, and 38 through 42. All right, ladies and gentlemen, have fun.